Welcome to the deep dive. For you listening right now, our mission today is well, we're going to explore a stack of highly technical sources that deal with what we are calling the trillion-dollar blind spot.
Right, the enterprise software blind spot.
Exactly, the trillion-dollar blind spot of enterprise software failures. And we are pulling from some really fascinating writings by deep tech operator Prasad Bond.
Yeah, his stuff is incredibly detailed.
It really is. Plus, we have comprehensive market analyses from Concord ERP and ECI Solutions, and these technical system migration briefs from Shift Asia, because we really want to figure out why these massive, like multi-million-dollar digital transformations just keep crashing and burning on the launch pad.
And they really do crash and burn. I mean, to do that effectively, to really understand it, we're looking at this entirely through a very specific and I think highly relevant lens. We're taking Dieter Rams' legendary design philosophy.
Oh yeah, the Braun guy.
Exactly, the industrial designer. We're taking his principles, specifically his principles of functional clarity, the extreme reduction of noise, and human-centered simplicity. And we're applying them to the incredibly chaotic world of digital transformation and supply chain physics.
Which is such a wild crossover, right? Because
Yeah.
Dieter Rams is usually associated with like industrial design. He's the patron saint of functional clarity. I mean, his philosophy is all about less but better. A product has to be understandable, it has to be unobtrusive and honest. But as we're going to see today, the enterprise software industry and the executives who are buying into it, they seem to be operating on the exact opposite principles.
It is a really striking contrast because, we're not just talking about an IT problem today. If it were merely a coding error, an IT department would have just issued a software patch and moved on.
Right. You just download the update and you're good.
Yeah, exactly.
Yeah.
But the failures we were examining, they represent a fundamental collapse in what Prasad Bande calls supply chain physics. And it's heavily mixed with organizational psychology.
Okay, let's unpack this, because usually when we talk about a diagnostic process, there's this expectation of precision. Like if you break your arm, the x-ray shows a jagged white line on a black background, right? The doctor points to it and says, there is the fracture.
It's binary. It's very visible.
Exactly. But you step into the world of digital enterprise systems and global supply chains, and suddenly that diagnostic x-ray machine is just completely broken. We're looking at a landscape where companies spend 10 million, sometimes hundreds of millions of dollars on these pristine, state-of-the-art enterprise software packages.
They think they're buying a digital savior.
Yes, a digital savior. But what actually happens on deployment day? The entire factory floor grinds to a mechanical halt. And the culprit isn't a massive server fire or a cyber attack. The culprit is literally a single invisible space character hiding in a 20-year-old spreadsheet.
Yeah, that invisible space, it really represents the ultimate diagnostic blind spot. I mean, we are dealing with systems so thoroughly layered and so complex that a microscopic error in legacy data, just a tiny bit of digital noise, can paralyze a multinational physical operation.
Which is just mind-bending. Let's start by defining the sheer scale of the problem, because before we can talk about fixing the machine using Dieter Rams' principles of simplicity, we really have to understand how staggeringly complex the current landscape is. We are talking about the ERP market, enterprise resource planning software.
The digital brain of a company.
Right, the thing connecting finance, HR, inventory, operations, all into one dashboard.
And it is a massive industry. I mean, according to Concord ERP's market analysis, this sector is experiencing an unprecedented capital influx right now. The global ERP software market size, it's estimated at $77.08 billion for 2025.
Wow.
And the trajectory, it projects it hitting an astonishing $157 billion by 2033. It is a massive global undertaking. And Concord ERP specifically highlights the incredible cloud ERP boom happening in India right now.
The India data is really fascinating because it's largely driven by external regulatory pressures, specifically their GST or goods and services tax compliance requirements, alongside initiatives like Digital India.
Right, which forces adoption.
Exactly. When a government overhauls its entire tax structure, every business essentially has to rewire its digital nervous system just to comply. India's market alone was valued at $4.5 billion in 2024 and is expected to reach $11.5 billion by 2035. They captured over 17% of the global cloud ERP market in 2025.
And that kind of regulatory pressure, it forces adoption timelines. Companies aren't always migrating because they want to optimize, They are migrated because they legally have to comply. And here is where the contradiction really emerges. Despite those billions of dollars pouring into the space, the failure rates are catastrophic.
Catastrophic is the right word for it.
It really is.
Yeah.
Widely cited industry analyses show that between 55% and 75% of all ERP implementations fail to meet their core objectives.
75%. That is unbelievable. And the numbers get even more severe depending on the specific sector. Like Panorama Consulting Group's 2025 ERP report reveals that in discrete manufacturing, 73% of ERP projects fail to meet their objectives.
Yeah, and we are talking about cost overruns averaging 215% above initial budgets. 215%. Gartner's projections are just as grim. They predict that by 2027, more than 70% of recently implemented ERP initiatives will fail to fully achieve their original business goals.
I mean, when you see a failure rate of 70% across an entire global industry, you have to assume the underlying methodology is fundamentally broken. It's not just a run of bad luck.
No, not at all. And to understand the root cause of that 70% failure rate, we have to look at the foundations these new systems are built upon. Shift Asia's technical brief on legacy system migration, it provides a very clear picture of this technical debt. Because aging systems, they demand wildly disproportionate IT resources. Large enterprises are currently spending upwards of 70 to 80% of their entire IT budgets just maintaining existing systems.
Just to keep the lights on.
Exactly. Just keeping the lights on. That leaves barely a fraction of the budget for actual innovation or, meaningful transition.
So why is it so expensive just to maintain the status quo?
Well, you have escalating maintenance costs because you are relying on an increasingly scarce pool of specialists to maintain systems built on ancient architectures, like COBOL.
Oh, wow. COBOL.
Right. COBOL is a programming language from the late 1950s, yet it still underpins a massive percentage of global financial and inventory transactions.
That's terrifying.
It is. And the programmers who originally wrote these specific corporate systems, they're retiring. Furthermore, you have massive security and compliance vulnerabilities because these old mainframe systems, they simply do not get patched for modern web-based threats. And most critically for our discussion today, you have severe integration bottlenecks. Modern global business relies on seamless, real-time API-driven integrations.
Right, everything talking to everything else instantly.
Exactly. But legacy mainframe systems were designed for batch processing. They were designed to run overnight, not for real-time web communication.
So looking at this through the Dieter Rams lens, Rams argued that good design involves avoiding unnecessary complexity.
Right.
Good design is as little design as possible. But the enterprise software industry is effectively doing the exact opposite.
100%.
Instead of simplifying the architecture, companies are bolting shiny, new, incredibly complex web software onto radioactive, decaying historical data.
And it creates a wildly unstable ecosystem. I mean, the executives buy the new ERP expecting it to cure all these operational inefficiencies. So the new system is brought online, it connects to the legacy database, and it ingests all that toxic historical data flawlessly. The modern software algorithms just assume the data they are fed is pristine and accurate.
Okay, the analogy that comes to mind here, it's like fluid filtration. It's like buying a state-of-the-art $1 million sports car. The engine is a masterpiece of modern engineering. But instead of premium fuel, you're pumping raw, muddy water from a swamp directly into the tank.
That is exactly what it is.
And you wouldn't blame the engine when the piston seizes up, right? The engine did exactly what it was mechanically bound to do. But in the corporate world, the executives sit in the boardroom looking at a stalled factory, and they point the finger at the new software.
Yeah, the executives wonder why the sports car won't do 0 to 60 in 3 seconds, completely ignoring the fact that the fuel lines are clogged with mud. And, cleaning that mud is an entirely different operational discipline than buying the car.
For sure. Think about your own workplace, for you listening. Consider how often a new application or a beautiful analytics dashboard is unveiled by the executive team, usually with like a massive PowerPoint presentation.
Oh, always a huge presentation.
Always. But behind the scenes, you, the user, you know for an absolute fact that the data feeding that dashboard is secretly held together by a terrifying 15-year-old Excel spreadsheet that only one specific person in accounting even knows how to update. The dashboard is the shiny sports car. The spreadsheet is the muddy water.
That is a very real scenario in so many companies.
Huh.
And moving from the macro-level statistics of these billion-dollar markets down to the micro-level reality, we really have to examine the physical manifestation of this digital decay. What actually happens on the factory floor when that corrupted legacy data hits the modern execution engine.
And this brings us to Prasad Bond's concept of supply chain physics, which is just a crucial reframing of the problem. He argues that in most of these disasters, the software didn't actually fail.
No, it executed its logic perfectly.
Right. It just perfectly executed corrupted instructions.
And it forces us to stop treating these as IT bugs. I mean, if a developer programs an edge AI system to manage warehouse inventory and sets a parameter that says, halt production if a critical sensor is out of stock, that software is performing its duty.
It's doing its job.
Exactly. If the legacy database reports the sensor is in stock, but the physical steel shelf in the warehouse is actually bare, the ensuing production line shutdown is not an IT problem. It is a fundamental disconnect between the digital map and the physical territory.
Yeah, Prasad shares a highly visceral story in his writings that perfectly illustrates this disconnect. He mentions that his relatives, they believe he designs advanced industrial robotics, so they picture him in this pristine, futuristic lab.
Like Tony Stark or something.
Exactly. But the unglamorous reality of deep tech operational engineering is that he frequently spends a Tuesday afternoon hunting down a single trailing space in a legacy CSV file.
A trailing space.
A trailing space. Just a blank, invisible character at the end of a string of text. And that single microscopic data anomaly resulted in 4,000 meters of anti-odor textile being misrouted to a condemned warehouse.
We really need to understand the mechanics of how a blank space does that. Because in a legacy system, data is often exported in CSV formats, comma-separated values. If a legacy data entry clerk 20 years ago accidentally hit the space bar after typing a warehouse location code, say they typed warehouse A and then hit space, that invisible space is saved in the database forever.
Just sitting there like a landmine.
It's literally like a landmine. When the modern ERP system, which requires absolute programmatic precision, when it tries to match the string warehouse with the legacy string warehouse, say with a space at the end, the SQL database logic registers them as two entirely different locations.
Because to a computer, a space is a character.
Yes. The logic fails to find a match, defaults to an error handling protocol, and suddenly, physical trucks are moving thousands of meters of heavy, expensive material to a secondary incorrect location.
So the digital typo forces a massive physical consequence. The executive dashboards forecast an immediate 15% bump in operational efficiency post-launch. But the ground-level reality is a sudden mechanical stall because of a spacebar tap from, 2004.
Let's expand on the bin 42 scenario he describes, as it is just the ultimate example of this physical consequence. You have an organization that upgrades to a fully automated warehouse system.
Right, millions of dollars in robots.
Yeah, robots everywhere. But the legacy system contains a ghost record for a discontinued robotic actuator. This legacy data, which hasn't been audited in years, maps this non-existent component to a specific physical location, bin 42.
Okay, so the new $10 million ERP ingests this database. So the new system's logic absolutely believes there is a vital part sitting in bin 42.
Exactly. At 4 a.m., an automated warehouse forklift, an AGV or automated guided vehicle, receives an API payload instructing it to retrieve the component for a critical maintenance ticket. The forklift physically navigates through the warehouse grid to bin 42. It extends its sensors to scan the pallet, but the physical component was discontinued and scrapped 2 years ago. The bin is physically empty.
And if the bin is empty, a standard automated forklift doesn't have the contextual human awareness to just, look around, shrug, and check the next shelf over. It's going to hit a logic wall and freeze.
It stalls out entirely. The vehicle's onboard PLC, its programmable logic controller, it encounters a physical reality that contradicts its API instructions. It cannot complete the task, and it cannot move forward without authorization.
It's just stuck.
It's stuck. And worse, automated warehouse grids are highly orchestrated environments. To prevent collisions and unpredictable behavior when a single unit goes offline, the safety protocols trigger. The entire routing grid locks down. Dozens of automated vehicles freeze in place.
Wow. So a 20-year-old corrupted Excel row effectively negotiated a suicide pact with a state-of-the-art robotics fleet.
That is a great way to put it. And consider where the burden of this systemic failure ultimately falls. It does not fall on the executive who signed the vendor contract in a nice office. The burden falls entirely on the frontline operator. A human worker has to physically enter this lockdown automated zone, climb the heavy-duty steel warehouse racking, visually confirm the bin is empty, and manually clear the digital queue on a localized terminal just to reset the grid.
And this is exactly where Bond introduces the concept of restorative engineering. It's the core philosophy that technology must protect and restore human capability. It must elevate the user. It must never degrade operator dignity through system-induced gridlock.
Right. When a frontline worker has to perform dangerous manual overrides to bypass a digital hallucination,
Uh-huh.
and let's be clear, a hallucination caused entirely by an executive leadership team's refusal to clean their legacy data, that is a profound failure of organizational design. You are forcing a physical mechanic to fix a digital oversight.
You deployed millions of dollars of technology that ultimately stripped safety and capability from the human operator.
Exactly.
But hold on, I want to push back on the structural assignment of blame for a second. If a system crashes because a bin is empty, why isn't the software engineering team held accountable? Shouldn't the developers have written better exception handling code to manage a null physical state? Like, why give the developers a pass?
It is a valid challenge, for sure, but it fundamentally misunderstands the architecture of enterprise data flow. An ERP system is fundamentally designed to act upon the data it is fed, not to psychoanalyze it.
Okay, fair.
You can write exception handling for a sensor failure or, a network timeout, but if the foundational master data, the agreed-upon truth of the business, states that an item exists, the logic must operate on that assumption. The failure here lies squarely with the control point owner, typically the chief data officer or CDO.
So the developer built the engine to spec, but the CDO authorized the muddy water.
The CDO owns that choke point. The problem is really one of corporate incentives. Cleaning historical data is invisible, tedious, unglamorous labor. It involves thousands of hours of manual verification and cross-departmental arguments over data definitions.
Nobody wants to do that.
Nobody. It is infinitely more glamorous for a CDO to present a shiny new user interface to the board of directors than to stand up and admit that the company's historical database is a toxic disaster zone. They are often terrified to halt a high-profile migration just for data hygiene, so they push the migration through, hoping the system will somehow just sort it out. And the operator on the floor pays the physical price.
Which utterly destroys employee trust. I mean, you cannot expect to minimize employer resistance to a massive digital transformation if the very first thing the new system does is make their physical job significantly more dangerous and frustrating. You are effectively gaslighting your own engineering and operational teams, telling them the new system is perfect while they're climbing steel racks at 4 a.m. to fix it.
And connecting this back to Dieter Rams, good design makes a product useful, and it makes it understandable. A system that hallucinates inventory, locks down a warehouse, and forces manual intervention is fundamentally hostile design. It is the antithesis of a user-centric approach.
Yeah, that single-stalled forklift is a microexample of supply chain physics failing. But what happens when you scale that Bin 42 ghost record across a global supply chain? The financial damage isn't linear, it becomes exponential. We have several famous historical disasters highlighted by ECI Solutions and Concord ERP that prove this isn't just theoretical fear-mongering. Let's examine what happened to Hershey's back in 1999.
Oh, the Hershey case study is essential reading for any executive attempting a systems migration. In the late 90s, Hershey's was attempting a massive overhaul, transitioning to a complex, multi-vendor ERP environment. They were integrating SAP's R3 ERP, Manugistics for supply chain management, and Siebel systems for customer relations.
And just getting 3 massive enterprise systems to talk to each other is a monumental architectural challenge even today, let alone in 1999.
Exactly. The initial recommended timeline for this project, accounting for the necessary data cleansing, integration mapping, and user training, was 48 months. However, Hershey's leadership felt extreme pressure regarding the impending Y2K deadline.
Ah, the Y2K panic.
Yes, so they made an executive decision to compress a 48-month architectural project into a 30-month timeline.
Which is insane. You simply cannot compress time in software architecture without severe structural consequences. I mean, Dieter Rams dictates that good design is thorough down to the last detail. You cannot be thorough when you slash a year and a half off a data migration schedule. What actually broke inside the system because of that compression?
Well, by rushing the timeline, they severely curtail the critical testing phases. Systems integration testing, which is basically verifying that an order placed in SAP actually triggers the correct fulfillment logic in Manugistics, that was completely rushed. Furthermore, the cutover strategy was deeply flawed. Instead of a phased rollout, they opted for a big bang deployment.
Just flip the switch on everything all at once.
Right. And in a move of truly remarkable strategic blindness, they chose to go live with the new, untested system right before their peak season, Halloween.
Oh, no. Which is when a candy company generates a massive portion of its annual revenue. Did the system just crash from the load?
It wasn't just server load. It was a total breakdown in supply chain physics. The order processing system disconnected from the warehouse fulfillment system. Hershey had plenty of candy sitting in their warehouses. The physical inventory existed. But the new ERP system couldn't process the digital orders and route them to the physical fulfillment centers.
So the data was completely severed from the reality.
Distributors were ordering candy, but the system couldn't tell the forklifts to load the trucks. They were unable to fulfill $100 million worth of orders. Hershey reported a 19% drop in quarterly profits, and their stock price fell by 8%.
They literally starved in a warehouse full of food because the digital map lost track of the physical territory. Unbelievable. Another massive failure from their era was Nike in 2001. They invested $400 million into a new supply chain and ERP system, heavily focused on demand planning.
Yeah, Nike implemented a demand planning software from i2 Technologies. The goal was to predict exactly how many of each shoe style they would need based on market trends. But the predictive algorithms hallucinated wildly. They ended up producing massive overstocks of certain low-selling shoe models while simultaneously experiencing severe stockouts of the highly demanded Air Jordans.
But why did the algorithm hallucinate? I mean, an algorithm is just math. What fed the math?
The demand planner relied on historical sales data to build its predictive models. But the legacy data Nike fed into the system was deeply flawed. It contained inaccurate product lifecycle metadata and inconsistent categorizations.
The muddy water again.
The muddy water. And when you feed noisy historical data into a highly sensitive predicted algorithm, the algorithm amplifies the noise. The mathematical feedback loop convinced the production software that a discontinued style was trending while ignoring the actual market signals for current models. They lost over $100 million in sales, and their stock dropped 20%.
And then there is the cosmetics giant Revlon, who faced a massive class action lawsuit from their own investors after a botched ERP rollout led to $64 million in lost, unfulfilled shipments, dropping their stock almost 7% in a single day. The lawsuits alleged that management knew the integration wasn't ready but pushed it anyway. But here's where it gets really interesting. The case study that truly exemplifies a failure of Dieter Rams' principles is the Lidl disaster.
Oh, the Lidl scenario is staggering in its financial scale. Lidl, the massive European supermarket chain, they spent 500 million euros, which is roughly $545 million, on an entirely new ERP implementation powered by SAP HANA. They spent 7 years trying to build and deploy this system. 7 years.
Wow.
And at the end of it, they abandoned the project entirely and reverted to their old system, writing off €500 million as a total loss.
€500 million up in smoke. And when you dig into the core reason why the project died, it wasn't because of server crashes or cyber attacks. It was a failure of functional clarity regarding a single business rule.
Exactly. It exposes a profound disconnect between the software vendor's architecture and the reality of the client's business model. Lidl's existing legacy inventory system had historically operated by valuing inventory based on purchase prices. This was baked into the DNA of their entire accounting and logistics workflow. However, the new SAP software was fundamentally architected to calculate and value inventory based on retail prices.
Wait, that is a fundamental, foundational mismatch in how the entire business calculates its core value. How does an integration team spend 7 years and €500 million without resolving that?
Because neither side wanted to adapt to the other. To make the new software work, Lidl would have had to completely restructure their internal business logic to match the software's retail price architecture. Conversely, to make the software match Lidl's purchase price reality, the developers had to write an immense amount of custom code, breaking the standard functionality of the ERP.
So they just fought each other for 7 years.
Pretty much. They spent years trapped in a customization nightmare, trying to force a square peg into a round hole, before finally realizing the system had become too complex and unstable to ever deploy safely.
It goes directly back to Rams's idea that a product must be understandable and honest. If the software speaks the language of retail and your entire operational history speaks the language of purchase, you aren't communicating, you are just generating friction. Which brings us to the operational reality. Knowing these case studies, how do leadership teams actually prevent these budget-destroying failures? ECI Solutions provides a roadmap, starting with how you evaluate the software vendors themselves. They warn very explicitly about the vendor trap.
The enterprise software sales cycle is highly polished. Vendors will come into the boardroom and project absolute confidence. They offer pristine feature checklists and beautifully sanitized product demonstrations, making it appear as though their software can seamlessly integrate into any environment and solve operational bottlenecks effortlessly.
It's the equivalent of a Hollywood movie trailer that only shows the explosions and the kissing scenes, completely hiding the fact that the plot makes absolutely no sense. The roadmap dictates that you cannot make a multi-million-dollar architectural decision based on a sanitized demo.
Yeah.
You have to change the rules of the vetting process.
The core of a successful vendor evaluation is taking control of the demonstration. Do not ask the vendor to show you what their software can do. Demand that they prove it using your reality. You take a cross-section of your messy, radioactive, inconsistent legacy data and you hand it to them.
You literally hand them the muddy water. Run your sports car on this.
Precisely. You force the vendor to ingest your actual data, complete with the null values, the trailing spaces, the duplicate records, and the bizarre formatting anomalies, and you demand they execute your specific business processes under stress conditions. If their pristine software crashes during a boardroom demo because it encounters a missing zip code in your CSV file, you now have a highly accurate preview of what will happen on your factory floor at 3 a.m.
Right. You have to evaluate data quality compatibility early in the procurement phase before any contracts are signed. Because once the ink is dry, fixing that compatibility gap becomes your financial problem, not the vendor's. This also requires a deep understanding of your own workflows. An ERP project is rarely just an IT purchase. It is a full-scale business transformation. You have to map your current physical workflows to identify where the bottlenecks actually are.
This is a critical distinction. Many organizations make the fatal error of simply taking a broken, inefficient physical process and paying millions of dollars to digitally replicate it. If your warehouse routing strategy is chaotic and redundant on paper, digitizing it just means you execute chaotic redundancy at the speed of light.
Just making bad decisions faster.
Exactly. You must use the migration as an opportunity to simplify the workflow itself, applying Jeter Ram's philosophy to the business process before applying it to the software.
But how do you empirically know if you are actually transforming a process versus just slapping a very expensive digital Band-Aid on a broken leg? What are the metrics of true transformation?
You measure it by tracking tangible business process improvements, not by tracking software deployment milestones. Going live is not a success metric. It is a start date. According to Panorama Consulting, successful organizations track specific shifts, achieving a 91% reduction in specific operational costs, realizing a 90% gain in process productivity, or significantly reducing time to market for a product. If the new software does not move those physical metrics, it is not a transformation.
Jeter Rams would ask, is the process actually better, or is it merely newer? And if the people doing the work don't believe it's better, the project dies anyway. You can survive a bad vendor demo, and you can map the perfect workflow on a whiteboard. But if the human operators refuse to use the system, the digital transformation fails.
Yeah, the psychology of the transition is often the most neglected aspect of a migration. According to industry analyses, inadequate change management is the primary root cause in over 42% of all ERP implementation failures.
42%.
Yeah. Organizations obsess over server architecture and completely ignore organizational psychology. Technology does not inherently resist change. Human beings do.
If the executive suite hands down a massive, radically different workflow system on a Friday afternoon and expects the frontline warehouse workers to flawlessly embrace it on Monday morning, they are engineering their own failure.
To minimize this resistance, leadership must prioritize team psychology early. You need a structured roadmap that brings key frontline employees, the actual end users, who will be operating the scanners and the terminals into the project during the requirements gathering phase. When operators feel their operational reality is being respected and integrated into the design, they develop a sense of ownership over the new system, dramatically reducing friction during deployment.
It is fundamentally about respect, and that requires very specific executive communication habits. You cannot just issue a memo detailing how to use the new interface. You have to continually explain the why. Why is the current legacy system a threat to the company's survival? Why is this specific pain of transition necessary for the long-term stability of everyone's jobs?
Furthermore, executives need to appoint and empower internal champions. These are respected individuals within the operational teams who understand both the technical goals of the new software and the complex, undocumented internal office politics.
Right, the people who actually know how the place runs.
They act as translators between the IT architects and the factory floor.
Yeah.
But the most delicate psychological challenge in this entire process is dealing with what Shift Asia identifies as the tribal knowledge problem.
Oh, man. Tribal knowledge is the lifeblood of almost every mid to large company I've ever looked at.
It absolutely is. A shocking amount of a company's true operational logic does not exist in any database, training manual, or workflow diagram. It exists exclusively in the memories of veteran employees who have been executing the processes for decades.
Right.
They know the undocumented workarounds. They know that a specific vendor always ships their barcodes slightly misaligned, so they know to scan them at an angle. They know that on Tuesdays the loading dock gets congested, so they route certain shipments through the side door.
They are the human duct tape holding the rigid, broken legacy systems together.
Exactly. And when an integration team comes in with a multi-million-dollar software package and essentially implies that the veteran's 20 years of hard-earned experience is now obsolete because an algorithm is going to take over, you will face severe active resistance.
Of course you will.
You have to approach these veterans with immense respect. You must carefully and collaboratively extract that tribal knowledge so it can be built into the new system's rules engine, and you must do it without degrading the employee's dignity or making them feel expendable.
If we synthesize this psychological element back into Ram's philosophy, a digital system is not truly user-friendly just because the graphical interface has a minimalist aesthetic and sleek buttons. True simplicity includes emotional and psychological simplicity. A system is user-friendly if the user actually understands its purpose, if it accurately reflects their physical reality, and if they trust that it won't ruin their shift by locking down their forklift over a ghost record. User trust isn't a bonus, it is a foundational, functional requirement.
That is the exact operational definition of human-centered design. However, let us assume an organization has executed perfectly up to this point. They've aligned the team's psychology, they have extracted the tribal knowledge, and they have thoroughly stress-tested the software vendor. They still face the ultimate technical hurdle. They have to sanitize the radioactive legacy data before they flip the switch on the new system.
We need a Dieter Rams-style extreme reduction of noise. We need to sanitize the past so it doesn't corrupt the future. And this is where Prasad Bond's operational rigor becomes vital. He advocates for what he calls information fasting and the 48-hour protocol.
Information fasting is a radical conceptual shift. As migration day approaches, executives tend to panic and demand more abstract planning sessions, more PowerPoint presentations, and more theoretical projection models. Information fasting demands that leadership stops trusting these abstractions. You stop looking at the map and you start looking exclusively at the territory.
Okay, so what do you look at?
You trust only two things. The raw API payload logs the actual data moving between servers and the physical inventory sitting on the steel shelves.
The digital map is an illusion. The physical shelf is the ground truth.
To force this alignment between data and reality, Bond introduces the 48-hour protocol. He argues that endless planning cycles often mask a fear of execution. His directive is harsh, but effective. Cancel your final alignment meetings. Stop theorizing about the migration weekend. Force the engineering team to deploy a functional data cleansing proof of concept within 48 hours.
Mandating a functional deployment in 48 hours is incredibly aggressive. What are the actual technical mechanics of executing that? How do you clean decades of data in 2 days?
You don't clean it all. You prove the cleaning mechanism. It requires extreme parameter engineering. First, you extract a microbatch of legacy data. You do not try to parse the entire database. You pull a maximum of 5,000 rows, a small, highly contained sample.
Okay, you isolate 5,000 rows of the muddy water.
Then the data engineering team runs a Python script, typically utilizing the Pandas data analysis library to aggressively isolate anomalies. They use regular expressions or regex, which is a sequence of characters that specifies a search pattern.
Wait, so it's searching for a pattern?
Yes. They use regex to actively hunt for the microscopic noise, flagging null values where a number should be, identifying those invisible trailing spaces we discussed earlier, and catching formatting mismatches.
You are building a digital filter to catch the digital noise.
Crucially, you impose severe computational constraints. You force the validation scripts to execute in under 200 milliseconds. If the script takes longer than that to validate the 5,000 rows, your logic is too complex and will fail at scale. This constraint forces the engineering team to strip away unnecessary computational steps and focus entirely on the most critical operational choke points.
It is the ultimate expression of less but better. You strip away everything until you isolate the exact, specific row of data that causes the logic to crash.
Once you microtrack the exact SQL row that stalls the process, you don't write a 50-page autopsy report. You write a 150-word brief identifying the specific system blockage. You deliver this brief directly to the chief data officer, and you demand a binary yes or no decision. Do we halt the deployment until this specific schema is sanitized, or do we proceed and accept the ensuing factory shutdown?
Wow.
You force leadership to look directly at the reality of the bad data.
But Bonds doesn't just diagnose the problem, he outlines a specific architectural strategy to fix the data flow asynchronously using an N8N framework. Let's pause and clarify this for anyone who isn't deep into API integrations. What exactly is an A8N framework and how does it clean the data?
Think of an AN as a visual workflow automation tool. It allows you to connect different APIs and databases using a series of logical nodes. Instead of trying to manually clean millions of rows of historical data in the legacy database, which is often impossible due to the legacy system's rigidity, you build an autonomous digital water filtration system between the old system and the new one.
So it sits in the middle, intercepting the data in transit.
Exactly. You connect an N8N webhook to the legacy system's export trigger. When the old system attempts to send a JSON payload, which is just the standard format for transmitting data objects consisting of attribute value pairs, the webhook catches it. The payload hits this checkpoint before it is allowed to enter the master database of the new ERP.
The legacy data is pumped in, but it has to pass through the filter first.
The workflow passes this JSON payload through a rigid code node constraint. This node applies the Python regex logic we discussed. It acts as the carbon filter. It automatically strips trailing spaces from strings, checks for missing Boolean values, and ensures date formats are unified.
And what happens when a piece of data is too corrupted to be fixed automatically, like if it's just completely mangled?
This is the brilliance of the asynchronous design. If a payload fails the logic test, the system routes that specific, isolated error to a designated Slack channel for a human data engineer to review and manually correct. But if the payload passes the test and is sanitized, it is routed directly into the master ERP database.
So the new $10 million system only ever ingests pristine, safe, verified data. The muddy water never reaches the new engine.
Precisely. You sanitize the incoming payloads asynchronously, catching the digital typos before they are ever allowed to trigger physical, mechanical movements on the factory floor.
So what does this all mean? When we step back and look at the totality of this, the $157 billion market projections, the terrifying 70% failure rates, the ghost records paralyzing automated forklifts in Bin 42, and the intense rigor of the 48-hour protocol, it all converges on one undeniable truth. Clean data is not an abstract IT preference. It is a fundamental physical safety requirement.
It is the absolute foundation of supply chain physics. If the data is toxic, the mechanical machine stops. And when the machine stops, it is the human worker who suffers the consequences.
For you listening, the ultimate takeaway from this deep dive is a recalibration of what transformation actually means. True digital transformation is not achieved by writing a massive check for a magical software package. You cannot buy your way out of a messy, undocumented reality. True transformation requires auditing your physical reality. It demands applying Dieter Rams' philosophy of simplification to your business processes, ruthlessly shedding unnecessary complexity. And above all, it requires a system architecture that protects the dignity and the safety of the people doing the actual work on the floor.
If an organization fails to build systems that respect both the human operator and the physical reality of the business, they're not engineering operational solutions. They are simply engineering gridlock at a higher price point.
Which leaves us with a final, somewhat unsettling thought to mull over, building on the concept of tribal knowledge we discussed earlier.
Consider your own organization's structure. If your multi-million-dollar company's daily operational survival relies almost entirely on the undocumented memories, the personal relationships, and the manual workarounds of just 3 or 4 veteran employees, is your business actually a well-designed, scalable machine? Or is it simply a fragile human ecosystem masquerading as a machine? And if it is the latter, what happens to that entire ecosystem the day those veterans finally decide to retire?
That is a terrifying and absolutely essential question for any executive to ask before signing a software contract. Thank you so much for joining us as we explored this trillion-dollar blind spot today. Keep questioning the dashboard, demand functional clarity, and above all, keep your data clean. We'll catch you on the next deep dive.